Designing Data-Intensive Applications by Martin Kleppmann, Chapter 1. In the previous video, we dealt with the preface. I thought we could get through the Chapter 1 as well, but it's just the preface. Now we're really in Chapter 1. Starts off with this quote from Alan Kay about how error-free the internet is. Like, what is this quote doing, man? I don't know. The internet's not super error-free. We get into this concept of what does it mean to be data-intensive. I really don't like this contrast with compute-intensive because there's not just two kinds of intensity in technology. There are other kinds of technological intensity like memory usage, I/O, human resource intensity, like manual labor, security and compliance, and so on. But I think it's sort of analogous to this thing that we do at interview time where we talk about the technical complexity, memory complexity, like space complexity, and then the runtime. And I think he's kind of making an analogy there, like runtime versus memory, but I think it's like not a clean analogy. And also these can be complementary. You can be compute intensive and data intensive. So I really don't like the whole, but what I do like though, is there are techniques for, I'm going to use the word big data. And he kind of argues that the word big data doesn't have much meaning. I think it does have meaning when you need to introduce like distributed data, parallelism. These are techniques that apply to large scale data. And so I think that's what it means to be data intensive. And those values of the book shine through, like whether or not you're compute intensive, like you can be both. He's going to say that he's dealing with data systems, but I think that's also wrong. I think this is just system architecture. And so for an example, he says that in a data system, you can allow users to search by keyword if you add a search index, but that's not true. If your users are going to do something, you need to have an API. And so it's not a pure database change, right? There's actually a whole system, and it's not a data system. It's just a system involved here. So, and then he talks about stores, like SQL, NoSQL, and so on. But many of these cases are useful, like batch processing. You can do this without a store. Later in the chapter, he'll talk about things that he doesn't cover, including deployment and build. But actually, build is a form of batch processing. It's a batch process where the output is files, and files are a form of data, actually. So all this to say that I really value this book. I'm not trying to knock on the book, but actually I think he undersells the concept of the book. I think what we're going to learn about with parallelism and distributed compute is going to apply to systems in general, not just data systems. So a lot of positive notes after that. Again, with that initial caveat that we call it DDIA, but really this can apply to all sorts of web scale systems. All right. So why refer to an umbrella term like data systems when you have different things like queues and caches? I think this is really intuitive if you're just familiar with the concept of data structures. Yeah, maps and array are different, but they're all data structures. So I think it's perfectly reasonable to refer to all of these things, whether it's Redis or Kafka, refer to all of them as data systems. So I think that's not controversial. He mentions what does a good API look like. So again, this is not just for data systems. This is going to apply to all sorts of systems. You can have an API that's just like a library, right? There doesn't need to be a database at all. I really like this mental model. That there are three concerns for software systems. He doesn't say data intense systems at this point. He says software systems. And that's reliability, scalability, and maintainability. Really, everything goes into these three buckets. At first, I wanted to say, what about technical efficiency and profit? But profit does fit into reliability because under his concept of reliability, that means the desired level of performance. Now, desired can be set by the business for profit reasons. That's fine. And so I love that he has this simple three-point model that includes profitability, and then scalability and maintainability. And everything that goes with developer productivity is going to fall under here, as well as operations. So I really like this mental model. He dives into reliability. One of the things that I think he misses is he doesn't talk about the concepts of nines of uptime, which is an industry standard thing. So he goes through the fundamentals, but he doesn't give us any of the industry norms. Like so reliability is important, but what's like, if I'm a new engineering director making a new system, what sort of reliability metrics should I be shooting for? He doesn't really answer that. But I would say that you want 3+ nines of uptime for a mid-sized company. Hardware faults, he does a really good deep dive, but then he says that we usually think of hardware faults as being random, and he skips over a really important concept that's really important in data-intense applications, web scale, cloud computing, and so on, is the idea of a regional outage, like a data center regional outage. So the hardware faults would not be random in that case. You would need to be prepared for like AWS region East 1 just completely going out. So those would be correlated hardware faults. So that's like a practical thing. Like your systems need to deal with regional outages. Otherwise it's good. Human errors, that's a really big deal. I'm so glad he covered this. Other books might just talk about technical errors and skip the human side. In terms of scalability, he says it's meaningless to say that Y doesn't scale. I think this just implies that there's a constraint and that the context can usually answer this. So as an example, I teach people to code, and I teach like it takes my own personal time, right? And that isn't scalable. So that business model doesn't scale. And you can clearly see what I mean by that. What I mean by that is there's 24 hours in a day, and I need to sleep. And so I think it's fine to talk about this as long as you have the context in mind. Describing load, this is great. He breaks it down and gives a concrete example with Twitter. I love it. He talks about the average and peak load. Average and peak are really great, but the minimum is also really important. Can I scale down to 0 is going to be extremely important. And then the median is also important. So the difference between mean and median, I think I don't need to tell you all this. It's an important difference between mean and median. But as a simple example, I love it. Describing performance, he just kicks butt. He goes through throughput and then wall time, the difference between throughput and wall time, and then SLOs and SLAs. He gets into percentiles here. And this is really important because SLOs and SLAs can be set by the business. And so this is a way that you can get into profit optimization by basically telling your users like, hey, this is how fast we are going to be. Again, he misses the industry norms. So I'll tell you that you want your web page to load in under a second is going to be one tip that I'll give you. So he doesn't have those like, I don't know, what would you call them? Rules of thumb, but the fundamentals are all there. I do wish he had more of those research-backed rules of thumb though, because again, if I am trying to build like a system like this for the first time, I need empirical data too, right? I need actual standards. I don't want to just know what an SLA means. I want to know what my SLA should be, like what's an actual recommended SLA. This is a minor thing. He says that an architecture is unlikely to cope with 10x. And I don't know why he says this. I'd love to get a cite for that. In many cases, a well-designed architecture can go multiple orders of magnitude. Maintainability. I like that he breaks it down into these three. I wish that he talked about quality and maturity, but it is included. Like you can argue this stuff is included in here, but just in terms of the normal way that we talk about it, like we usually talk about quality. Operability, we'll often call it usability. Again, it's the same thing and he talks about it and he's right, but just in terms of vocabulary for you, we'll do like usability studies and so on. He talks about evolvability, which we don't actually really use that term very often. But simplicity is important. Simplicity is going to make it easier to troubleshoot. We also talk about the ease of reasoning about a system or intuition, facilitating developer intuition. When he talks about managing complexity, a tip that I have that I don't think he touches on is you can literally limit your cyclomatic complexity with a static analysis, like with a linter, SonarQube, or something like that. It'll tell you that a function is too complex and you need to break it up into multiple functions. I got a little bit triggered. He talks about the use of abstraction to solve for accidental complexity. I find that hyper abstraction is a leading cause of accidental complexity. And I got triggered, but in particular, I'm being triggered by the concept of an abstract class. On another reading, in a general term, if you're including functions here under the concept of abstraction, then this is totally fine. But I would encourage you to think in terms of functions and modules before you start thinking about abstract classes if you're trying to reduce complexity. Wrapping it up here, he talks about keeping a system easy to change, but we also want to strategically salt and freeze. Wish he talked about that more. Really, really nice ending here that maintainability is really just making life better for the engineers and operations teams. Follow for chapter 2.